Now in this video we will try to discuss the monotonicity of the recursive sequence. In fact, the monotonicity of the recursive sequence cannot be defined directly using the terms of the sequence because we cannot use the terms of the sequence because maybe we don't have u0, the value of u0, the first term, but we know that u0 belongs to an interval that's mapped to itself, which implies that the sequence is well defined. Also, it depends on the variation of the function f, because f, if it's decreasing or increasing, it can have an influence on the monotonicity of the sequence un. So we have two major methods that we can use in this task to find the monotonicity of the sequence. Is first to compare f with the identity function. This is the first method that we can use. It helps to find directly the result. And also we have a second method that we can use is to study the variation of the function f. This is so important so we can understand so many things about the recursive sequence, and also it helps to find all the results that we are looking for the recursive sequence, not only for the monotonicity. Okay, let's start with the first method in this part, which is the study of the sign of un plus 1 minus un, because we know that to find the monotonicity of the sequence we need to find the sign of un plus 1 minus un. And this because the expression of un plus 1 is defined using un and f. We can replace it with f of un minus f. So to find the sign of un plus 1 minus un, you can use f of un minus un. This implies that it means that we need to find the sign of f of x minus x. And of course here whatever was x belongs to the domain of the function. And to find the sign of this function, it's not directly we can use the values of x to find the sign, but here we need to see the variation table of g of x, which is defined by f of x minus x. So only we need to see the variation table of g to decide if we have an increasing function or a decreasing function. So here, in summary, let f be a continuous function on j, and of course j here is mapped to itself by f and contains u0. This will indicate that the sequence is well defined. So if f of x minus x is positive, and this means that un is increasing, of course. And if f of x minus x is negative, it means that un is decreasing. So this is the first way to prove that the sequence is having a monotonicity with increasing or decreasing. And also it can help us to find different results with f of x minus x, because it's talking about we can with this function we can find also the fixed point. So this is the first way. The second way is to see the variation table of the function f itself and decide if we have monotonicity, we have an increasing function, we have monotonicity or not, and then we decide if it's increasing or decreasing, or if the sequence is not monotonic, then we will see a different way to prove the convergence of the sequence. So if we go to the variation of the function f, we see here different types. Of course, we can have a function f is increasing or the function f is decreasing. Of course, here we are talking about the j interval, and j here is mapped to itself. Okay, so we are not seeing the increasing the variation of the function on the domain, but only we will focus on j, the interval that contains all the elements of the sequence. So here we have, if the function f is increasing or j, it means that the sequence is monotonic. So we can find the monotonicity of the sequence. Here, of course, we can compare u1 and u0, and find the monotonicity. If U1 is superior than U0, then the sequence is increasing. If U1 is different than is less than U0, then the sequence is decreasing. But this method is only it can be done only if we have U0 is a finite limit, a finite value. It means that we know already the value of U0. But if we don't have the value of U0, then we will use the method of f of x minus x, the g of x, that will give us the sign of the sequence. So if the function is increasing, this means that the sequence is monotonic. Okay? And to find the monotonicity of the sequence, we can compare U1 and U0 and find which one is bigger than the other. And in this way, we can find the monotonicity of the sequence. And of course, this method is used when we have the value of U0. So we can find the value of U1 and we can make the comparison. But if we don't have the value of U0, we use the first method, which is f of x minus x. We find the variation of this function, and then we decide the monotonicity of the sequence. Now we move to the function f, which is decreasing, and this is different than the increasing one. So here, the function, if it's decreasing, in fact, the sequence is not monotonic. We cannot decide about the monotonicity of the sequence. The sequence is not monotonic, but we have the subsequences u to n and u to n plus 1 are monotonic in opposite directions. It means that if one of them is increasing, the other will be decreasing. So let's repeat. If the function is decreasing, the monotonicity of the sequence is not defined. We don't have a monotonic sequence, but we have two subsequences. The two major subsequences of the sequence un are monotonic with in opposite directions. It means that one of them is increasing and the other is decreasing. Of course, here we need to find the monotonicity of the sequences u to n and u to n plus 1. So we will use the function f round f. This is so important in our to define or to find the monotonicity of the two subsequences. We will use here f round f because f round f is defining the function that defines the subsequence u to n and subsequence u to n plus 1. So here the f round f, if you study the variation of f round f, we will see that f round f is always increasing, and this means that the two subsequences are monotonic, and you can find the monotonicity of the two subsequences using the method that we talked about in the case of the function is increasing, or we can use the comparison f of x minus x. Okay, so here when we have this, when we are in this case, we need to make sure that f round f is increasing. This is correct, whatever was the function f. And of course, we need to find the expression of f of round f. So we can use the variation table, and we can decide about the sequences or subsequences u to n and u to n plus 1, because the convergence of these two subsequences can make the convergence of the sequence un. If the two subsequences are convergent to the same limit, then we have the sequence un is convergent, even we don't know the monotonicity of the sequence un. And if the two subsequences are convergent to different limits or are divergent, then in this way we have un is divergent. So this is all. These are the methods that we can use to find the monotonicity or to discuss the monotonicity of the sequence un. Now we need to move to the convergence, so we can decide if the sequence un is convergent or not.